Welcome to this video. This is the third part of a series I am making about building your own robotic arm. Last time we looked into the math that makes a robot like this work. We solved this problem by just using geometry and high school math. Before we actually start building the robot and dealing with the hardware, I wanted to show you a virtual version of the robot. It is an exact virtual replica of the robot, and we can control it from the same UI we'll use for the real robot. This way, even if you don't want to deal with all the hardware, you can quickly get this virtual robot going and see it in action. For this entire series, I'll be using Ubuntu 24.04. This is important because I made everything using ROS Jazzy, which is a specific version of the robot operating system. So if you want it to work out of the box, I would highly recommend you use a dedicated Ubuntu 24.04 image for this. Right now, I'm using a virtual machine with VMware, and I simply downloaded and started a Ubuntu OS. This makes everything easier and isolated. I won't go into setting up a virtual machine with VMware because that is out of the scope of this video, but I'm sure there are many tutorials out there. Once you have your Ubuntu 24.04 OS running, you want to open a browser and go to the Git repository for this project. I'll be leaving a link for that in the description. At the start page, you can already see how to get started. We're going to be copying the clone link up here. You're going to open a terminal and run git clone with the address you just copied. After the repo is cloned, we'll go into the projects folder. Here you can see two scripts. One is called install_project.sh and the other is called run.sh. We first start by running the install script with bash install_project.sh. This may take a while, but it will download and set up ROS Jazzy and install all of the Python dependencies. After that is done, we simply need to run the run.sh script. Again, we use bash run.sh and you should see a prompt on the screen. It should be asking you if you want to run the dummy or the real robot. The dummy robot is exactly what this video is about. It is a simulated virtual robot, so go ahead and type dummy. It will then start all of the ROS nodes, and you should see a RVis window open up. RVis stands for ROS visualization. It lets us visualize our robot in 3D. In this window, you should already see the 3D model of our robot. Once all the nodes are running and the RVis window is opened, you'll need to open your browser once again and go to this address, localhost:8080/input. This is a website hosted by one of the ROS nodes that you just started, and it contains the UI for controlling the robot. It contains many different cards that let you interact with the robot. All of these cards are draggable, so you can change their order to your preference. This top card just gives you the current position of the end effector, that is the tip of the robot. These values are the XYZ distances from the tip to the base of the robot in meters. This second card lets you move the tip of the robot in any of the three axes. You can click on each one of these buttons to increment or reduce the XYZ positions by a certain fixed amount. The third card is just some simple actions the robot can perform. The switch open and close are just simulating the robot pressing a light switch. The robot can draw a circle or an SVG picture. In this case, it draws a cube. The line demo shows how the elbow position can change during the motion in case a certain target becomes impossible in the current configuration. The last card is the most useful one. It is the Path Programmer. It lets you capture different positions of the robot and replay them later. So you just move the robot how you wish with the second card. Once you reach the position you want, you click on Capture, and the current XYZ coordinates will be added to a list. You keep doing this process to save all the points you want, and then click on Start, and the robot will go to every point you saved, interpolating points in between so that it moves on a straight line between every saved point. This way, you don't have to hard code every motion you want to do. You can program it on the UI itself. But that is all that I have for this video. We quickly got the virtual robot working even before we touched any hardware. For those of you that actually want to build a physical robot, in the next video we'll look into 3D printing and putting all the parts together. Thanks for watching, and I'll see you in the next video.